Hi everyone. Today we're going to be discussing graphing linear equations in standard form. For our learning target today I can explain how to graph linear equations written in standard form. So let's see what this standard form is all about. Here in our key idea today it says the standard form of a linear equation is ax plus by equals c, where a and b are both non-zero. That might look like a lot of letters, but what I can tell you is most of the time, well, all the time actually, A and B and C will all be different numbers. Okay, A, B, and C will all be different numbers. So we'll just have X and Y left in that equation, and that's what we're kind of used to dealing with when we're graphing. So A and B can't be zero, and A, B, and C are all numbers. I'll kind of show you the process that we use to graph standard form equations. There's two main methods that we're going to use, and let's look at our first example here and how we're going to do it in example 1. It says graphing a linear equation in standard form. Graph negative 2x plus 3y equals negative 6. And you can see here now that A, B, and C are all numbers, just kind of like I said they were going to be. Okay, so the way that I'm going to teach you to do it, the first way is to write it in slope-intercept form. And if you remember, slope-intercept form is y equals mx plus b. Okay, where m is the slope and b is that y-intercept. And then we can really easily graph from there. Okay, so how do I do that? How do I take this equation and write it in this form? Well, notice that slope-intercept form is solved for y. So I want to go and I want to solve this equation for y. Okay, so the first thing I need to do is I need to move this negative 2x to the other side. You'll notice x and its coefficient are on the right-hand side of the equation. So I'm going to add 2x to both sides of my equation. Negative 2x plus 2x will cancel out, and I'll be left with 3y equals 2x minus 6. Notice I wrote the 2x first because in slope-intercept form, my mx comes first plus my b comes last. So that's why I did that. Lastly, then, I need to divide by 3. And when I divide by 3, I need to divide everything by 3. Okay, so that's going to leave me with y equals, and I can just leave this as 2/3 x, right? This is just my slope. That means up to, right, 3, minus, and 6 divided by 3 is 2. Okay, so now I've got a slope, and I've also got a y-intercept. Remember, that's where my line crosses the y-axis. Okay, so now I'm going to use this equation and I'm going to graph. Okay, so I'll start by making my y-axis straight as I can here, and my x-axis. Sorry, that's kind of messy. I should try to get that on the line a little bit better. There we go. And what do I know? What can I graph? Well, I know that the y-intercept is at negative 2. So I'm going to go down to negative 1, negative 2. And that's going to be my first point. And then from there, I'm going to use my slope. 2/3. So that means I'm going to go up to the right 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. That's the same thing as going down 2 and left 3. Notice that it's on the same line. Okay, I've got my points there, and I can connect them and graph that line like that. Okay. Go ahead and pause the video now to try first rewriting these standard form equations into slope-intercept form, and then graphing them to see how you do. Okay, hopefully you had a chance to do so. I'm going to try to graph these as quick as possible, so I'm not wasting too much of your time here. If you need more assistance on any of them, please be sure to let me know so I can help you. Let's do the first one together here, just so you make sure you understand it. I have x plus y equals -2. Again, I want to solve for y to put it in slope-intercept, so I'll subtract x on each side. Okay, that leaves me with y equals, again, I like to write my x first, so -x minus 2. And that's because in slope-intercept form, my x is written first. Okay, so that means I'm going to start, my y-intercept is at -2, so I'm going to go down to -2, and I'm going to plot my y-intercept right there. And then my slope is -1. And remember, -1 can be written as a fraction as -1 over 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. Same thing as up 1, left 1. Up 1, left 1. And there is my line. And hopefully that equation makes sense to you. Okay. For number 2, should look something like this. I'm not going to solve the equations here for these ones. I'm just going to graph them so you know. Looks like our y-intercept should be at 3. So like so. And our slope, I think, is up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. Same thing as down 1, left 1, 2, 3, 4. About like that. For number 2. Number 3. Looks like we're going to go through the origin. Oops. Man, this is trickier than I thought it was going to be on my writing pad here to stay on these small lines. So it looks like I'm going through the origin, or 0, 0. And it looks like my slope is 2/3, so up 2 over 1, 2, 3. Same thing as down 2, left 1, 2, 3. Okay, there we go. I feel a sneeze coming on, so if I sneeze loud, forgive me. There's my y-axis and my x-axis for the last one. And it looks like my y-intercept is about 5. 1, 2, 3, 4, 5 right here. And it looks like my slope is down 2, right 1, down 2, right 1, 2, right 1, down 1, 2, right 1. So it looks like that about right there. Okay. If you have questions on any of those, please let me know. Last thing that I want to point out is that it says here, use a graphing calculator to check your graph. Maybe you have a graphing calculator, maybe you don't. I don't blame you if you don't. They're like $100. I had to buy one in high school, but nowadays with the wonderful internet that we have like the program Desmos. So they have a free graphing calculator actually. So when you go to Desmos, the top thing here, it says graphing calculator. You can click on that. And then if you want, you can check your answers using the graphing calculator here. Might take a minute to load, but you just have to put in your equation. So for example, I'm going to make this a little bit smaller so I can do 2 things here. Or maybe I won't be able to, but we had x plus y equals -2. Let's check that for the first one. X plus y equals -2. And let's see what our line looks like compared to that. Okay, it looks like our y-intercept was at -2, which was the same here, 0, -2. And it looks like our x-intercept was at -2, same thing we got right here. So it looks to be accurate. Okay, so feel free to use Desmos graphing calculator if it tells you to double check your work right there. Might be something handy to do. All right, looking at the second example, it says graph x plus 3y equals -3 using intercepts. Okay, so this is the other way that I'll teach you that you can do it. Some students like this method because they think it's a little bit quicker rather than writing it in slope-intercept form, but I'll just kind of walk you through it here. So the first step when you're using intercepts is to find the x-intercept, you substitute 0 for y. Okay, so let's write that down. To find the x-intercept, substitute 0 for y. Okay, and then it's the opposite for the x, as I'm sure you can imagine. Okay, so to find the y-intercept, substitute 0 for x in your equation. And let me just briefly explain to you why. Why does that work? Well, look at any line. Let's say we've got this line right here. Okay, and I asked you for the x-intercept. That's the x-intercept, right? That's where that line crosses the x-axis. What would the coordinates for this point be? Well, let's just say I went over 1 and I went up and down. Well, I didn't go up and down any. The coordinate for this point would be 1, 0. So look at here. It's the same as the sentence I wrote up here. To find the x-intercept, substitute 0 for y, because your y value will always be 0 wherever your line intersects the x-intercept. And it's the same for the y-intercept, right? If I asked you for this point right here, which is the y-intercept, because that's where the line crosses the y-axis, well, you would say it's the x value is 0. We don't go over at all, and we go down maybe -1. Well, look, to find the y-intercept, substitute 0 for x. So that's kind of the reasoning behind why this works. Okay, so let's do that. Let's solve algebraically here to see. Let's use this equation. So x plus 3y equals -3. And let's substitute in 0 for y. Okay, so I'm going to substitute in 0 for y and then see what it gives me. Okay, so I have x plus 3 times 0 equals -3. Well, what is 3 times 0? Okay, 0. What am I left with? X equals -3. I've just solved for my x-intercept. Let's do the same for the y-intercept. My original equation is x plus 3y equals -3. To find my y-intercept, I'm going to substitute 0 for x. Okay, so I'm going to substitute in 0 for x. That would give me 0 plus 3y equals -3. Well, 0 plus anything is just that anything, so I don't really have to worry about it. I'm left with 3y equals -3. Divide by 3 on both sides, and y will equal -1. So here's my x-intercept, here's my y-intercept. I can come back to my graph. I can put on my y-axis, my x-axis, and then I can plot these two. I know that my line crosses the x-intercept at -3, so -1, 2, 3 on the x-axis, and it crosses the y-axis at -1. So again, I'll come down here, -1, and that's where it crosses the y-axis, and I will connect my two lines like so. Okay, so it's just a matter of substituting in 0 for y when you're looking for the x-intercept, and vice versa when you're looking for the y-intercept. Again, here's the reasoning why, and then you plot those 2 points and connect your lines to graph that. If you wanted to use decimals to double check, you sure as heck could. All right, one more example. We'll do the real life example, and then a few Oyos for you to try to end today. All right, example 3 says you have $6 to spend on some apples and bananas. Graph the equation 1.5x plus 0.6y equals 6, where x is the number of pounds of apples, so right here, and y is the number of pounds of bananas. So what that tells me is that I know that for each pound, right, of apples, because x is the number of pounds of apples, it costs 1.5, which means it's $1.50 per pound of apples. And for bananas, right, y represents the number of pounds of bananas. It's 0.6. So if I'm talking about money, that's 60 cents per pound of bananas. We know that you have $6 to spend. So that's why it says $1.50 times the number of pounds of apples you buy plus 60 cents times the number of pounds of bananas you buy has to equal that $6. That's the total that we have to spend. So first it wants us to graph this. So we can graph, and notice this is in standard form. AX plus BY equals C. So we have two methods that we could try. We could use the intercept method, just like we did here, or we could convert it to slope-intercept form. Either of those methods will work for this problem. And then it wants us to interpret the intercepts. So I'm going to highlight that just so I don't forget it. But that basically means, what does that mean in the context of the problem? What's the real life meaning behind the intercepts when we graph that? Well, I'm going to erase that. I'm probably going to be dealing with all positive numbers here is my guess. So I'm going to make my y-axis here, and I'm going to make my x-axis here. It's just kind of a guess, but since we're dealing with some positive numbers here, and it doesn't look like I'm talking about debt at all, I'm guessing I'm going to be graphing everything in the first quadrant. And the method I'm going to do is, I'm going to do like we just did, and I'm going to find my x and y intercepts. Okay. So to find my x-intercept, I'm going to plug in 0 for y. So that would give me 1.5x. 0.6 times 0 is just 0, equals 6. And then I just need to divide by 1.5 on both sides. 1.5 goes into 6 4 times. So my x-intercept is going to be 4. That'll be easy enough to graph. And my y-intercept, I'll show a little bit more work on this one just to make sure you get it. So 1.5x plus 0.6y equals 6. Again, when I'm looking for my y-intercept, I'll substitute in 0 for x. So 1.5 times 0 plus 0.6y equals 6. 1.5 times 0 is 0, so that's nothing. I'm left with 0.6y is equal to 6. Okay. Last step, divide by 0.6 on both sides. And what will I be left with? 0.6 goes into 6 10 times. So there's my y-intercept. Okay. If I look at my graph here, do I have 10 lines? 1, 2, 3, 4, 5, 6, 7. Not quite. I'm going to go by 2s. 2, 4, 6, 8, 10. I'll do the same on the x-axis. 2, 4, 6, 8, 10. And then I'll graph. My x-intercept is at 4. My y-intercept is at 10. Here is my line connecting the two. Okay, so I've graphed that equation. Letter B still says it wants to interpret that. Okay, well, the x-intercept shows that you can buy, remember, x stands for apples. You can buy 4 pounds of apples. So 4 pounds of apples when you buy, okay, if I were to buy 4 pounds of apples, well, 4 times 1.5 would give me 6. So I wouldn't have any money left over. So that would be 4 pounds of apples when you buy 0 bananas. Okay, and if you look at this point, it's 4, 0. My x, which stands for apples, is 4 pounds, and my y is 0. So I buy 0 bananas if I buy 4 pounds of apples. And likewise, I can say the same thing for bananas. The y-intercept shows that you can buy 10 pounds of apples, or excuse me, bananas, when you buy 0 apples, right? Because this point right here is 0, 10. So if I bought 0 pounds of apples, I could buy 10 pounds of bananas. I don't know who's buying 10 pounds of bananas, but hey, that's besides the point. So there you have it, graph and interpreting the intercepts. Okay, what these 2 points mean in the context of the problem. All right, lastly, it says for the on your own, graph the linear equations using intercepts. Use a graphing calculator to check your graph. So again, if you want to do, to use Desmos, please feel free to do so. Please pause now to try it out. Okay, I'm going to zip through these problems here. Here's going to be number 5, number 6, and lastly, number 7 here. And number 7 is going to be all in the first quadrant again. Okay, for number 5, looks like our x-intercept is at 4, 0. There, and our y is at 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. And then go ahead and connect your lines. For number 6, our y-intercept is at 0, 2. And our x-intercept is at 6, 0. 1, 2, 3, 4, 5, 6. Like so. And lastly, for number 7, we talk about oranges instead of bananas. So I'm still going to do that 4 pounds of apples. 1, 2, 3, 4. And instead now my y-intercept is going to be 5. So 1, 2, 3, 4, 5. And there is my line like that. And again, interpreting the intercepts for my x-intercept, that still means that I can buy 4 pounds of apples if I do not buy any oranges. And for this intercept, that means that I can buy 5 pounds of oranges if I don't buy any apples. Okay, so that wraps up standard form. Again, a couple different methods that you can do that with. AX plus BY equals C is standard form. And the couple methods we talked about to graph today were A, putting it in slope-intercept form, and B, actually solving for x and y to find the intercepts and graphing using the x and y intercepts. All right, thanks for checking this video out. I'll see you guys next time.